Purpose of design. The average drone will only fly around 10 minutes. The maximum flight time of a high-end drone is approximately 25 to 30 minutes. US-1 is a drone that has the longest battery life, it is approximately 2 hours. With this design, we can run longer flight time, longer than 2 hours, because it is going to be relying more on the energy of solar than battery. Why solar power? A drone battery is about $50 to $150 depending on the brand of the drone. Average lifespan of a battery is between 4 to 6 years. The average cost in Las Vegas would be $1.80 to charge the drone. 12-watt, 100-watt solar panel with amp charge controller is about $150. Average lifespan of a solar cell is between 25 to 30 years. A single solar cell can cost about $5. Designed for single motor parts. 2 9-volt batteries connected on series. Electronic speed controller. Arduino. Potentiometer. Brushless DC motor. DJI Phantom propeller were used. Image to the right is the Arduino program used as a control guide to run brushless motor. Designed for single motor circuit. The motor controlled by the Arduino ESC potentiometer. Potentiometer connected to Arduino, and Arduino is connected to the control wires of the brushless motor. This setup allows the users to adjust the speed of the motor with the potentiometer. From the single motor setup, the batteries will be replaced with solar cell. Image to the right shows the circuit connection followed by the information of the running motor such as frequency, maximum voltage, and minimum voltage. Solar cells. Solar cell information. 2 volt, 45 milliamps, 0.091. 30 by 30 millimeter dimension. The connection of the solar cells are 3 in series connected to 3 in parallel, resulting in 15 volts. On the positive side, there is a diode connected to ensure the direction of the current. Complete design. The complete design of the circuit would also involve chips such as op-amp to amplify, comparator to compare between battery and solar cell. A small research has been done that incandescent bulbs tends to charge the solar cell. This concept will be used in a temple charging drone solar panel to appropriate at nighttime. Project main difficulty. Not enough current is produced from solar cell panel. 2 solutions rose involving this concept. The first one, enhancement of solar cell, which involve more study in the choice of a proper solar cell. The second one, existing solar cell will be modified with circuit that includes op-amp in order to output a proper current. Currently, both solutions are in progress.